Okay, we're going to talk a little bit about some welding basics. Um, Welding symbols are included in the Inventor software. I'm not going to expect you to specify the welding type, but I will expect you to understand the welding symbols and how to apply them to a drawing, and this will be included in your final as well. You need to understand what these welding symbols mean and how they're generated in the software and how you put them in the software, and to kind of understand the different types of welding. Basically, welding is a form of bonding two like systems together, mostly metals. You can weld aluminum to aluminum, you can weld stainless steel to stainless steel, and you can weld steel to steel. You can even weld glass and plastic if you're a really good welder. But it's basically heating the two materials until they melt. Um, I thought it was kind of humorous when a lot of you weren't around or weren't really cognizant when we had 9/11 and the towers fell. But a politician got up, and I think it was a politician, it could have been a celebrity, and said basically, steel doesn't burn. That's the definition of welding. Steel is burning. You're getting it hot enough to melt to another piece of like metal. And if you get it too hot, it will atomize. I mean, it'll just go away. So the whole art of proper welding is to get the heat correct so that the two the two pieces bond together, and when you remove the heat, you've got a nice weld bead. I won't go any more detail on that, but I thought that was just something interesting to pass on when you see people who don't have any business making comments on news media and public television, and somebody who is in the know in the engineering world and knows a little bit about welding can look at it and go, these people need to keep their mouths shut, otherwise they really look stupid. So the first thing I'm going to do is I've put in here a sheet of weld symbols. And something important to remember, fortunately in most 3D software, the software puts the weld symbol in, and unless you are just grossly ignorant of what you're doing, you can easily insert the proper dimensions in the proper place. One of the things you've got to remember is this is where the weld is indicated, and something that is really interesting is no matter which direction the arrow is pointing, the size of the weld is always on the left side. You know, the size over here is on the left side. And here, the depth of the groove and the groove weld size is on the left side always, no matter which way the arrow is pointing. In a fillet weld, most of these, if you look at them, they make a lot of sense. A fillet weld looks like a chamfer, and it's a weld between one horizontal surface and a vertical surface, and the weld is right in here, and this size right here is the distance from the middle perpendicular to the root down here of the weld. Now, many times you will only have a fillet weld on one side. Sometimes you'll have a weld on both sides. In this case, this indicates a fillet weld on both sides of the um, piece that's being welded. So if you were to put a plate in vertical to another plate, you probably would weld it with a fillet weld at the root and then go to the other side of that plate and weld it. And generally, they would be of the same size. Not always, but of the same size. Now over on this side is the length of the weld. So you'd run this weld bead for 4 inches. It would be a 3/16 weld for 4 inches. In this case, a 1/4 inch weld for 6 inches. In this case, you've got a distance between the centers of the weld. So you would weld a 5/16 inch, which means from here to here is 5/16, and you would run a weld bead for 2 inches, and you would skip 6 inches from the center of this weld bead to the center of the next one would be 6 inches long. So you'd have a 2-inch weld with a space and then another 2-inch weld and a space, and the distance would be 6 inches. That's what all that means. Now the welds that we're going to be concerned with are going to be the fillet weld, which is pretty common. We're going to be dealing with a square groove weld or a butt weld, which is 2 plates butted together, and the root opening of an 1/8 inch in this case with a 3/16 inch weld. As you would expect, you want the weld to be larger than the opening, and this is only on one side, so you've got 2 plates butted together you have to have a little space in between them, otherwise you won't get a weld. You've got to have a gap, otherwise you won't get a weld. And the other thing you want, the welder has to make sure is he gets the voltage and the current correct so that he's getting a full melt through to weld without destroying the metal. He wants a full through weld. Otherwise the weld would be only a partial weld and you won't get a very good weld. So you have the square groove weld or butt weld, and then you have the other one that we're going to be dealing with is either a V groove. That's where you would take these 2 plates, and instead of having them squared edges, you would have a 40 or 45 degree angle on each plate so that you have a V groove between the 2 plates, and you can start at the bottom of this and weld up, and you end up with a weld in this V groove. I had this on a submarine where we had to build up. We couldn't get to the back side of the plate, so we had to put in a V groove by grinding or machining an angle on both pieces because the plate thickness was over 1 inch thick. And in order to do that, we had to start at the bottom, weld a bead, clean it up, weld 2 beads, clean it up, weld 3 beads, clean it up, and so on until we reached the top and filled it in with a final weld. Creates a lot of heat. You got to be very careful. You got to have a good welder that knows what he's doing. Otherwise, you're going to distort and twist very, very much. So what they have to do is they run a bead, go to another area, run a bead, let it cool, clean it, come back after it's cooled a little bit, and run another bead. So that's how they do that. The other one is where you've got a square edge and an angled edge, and this is a bevel weld. So you've got a bevel and a square. Those are the types of welds that we're going to be dealing with, and then you're going to have a flare bevel. This is very common where you have a square plate or a square tube. In the case of square tubes, they've got rounded corners. So if you put a cut piece of square tube where the edge is square up against another tube that's full tube and would have a rounded corner on it, you would end up with this flare bevel arrangement. It wouldn't be a square groove, it would be a flare bevel. So the symbol that you would use for that would be a flare bevel, and the weld size would of course be the size here. So those are the basic ones that we want to address. The others you can look at on your own, but I want to address those. And what I'm going to do is I'm going to swap screens here and go back over to the software, and we'll address this. All right, what we're going to do, we're over here in the software now, and I've got two plates here. I've got a beveled edge, I've got a chamfered edge, and I've got a filleted edge. But what's more important is these two plates. I've got a small space between these two surfaces, and if you look at the weld symbols, that's the square groove weld or the butt weld, and that's a typical, you've got to have a space in there for the welder to be able to weld it. So it's got to be a small space. Can't be too big because then it'll not be an effective weld. So the spacing on the plate when he goes to weld it has to be a fairly small open space for him to weld a square groove weld. If I were to add another type of plate here and look at this plate, this would be a flare groove. So what I've got is, I'm sorry, bevel groove. I've got the bevel on this plate, and I've got a square surface on this plate, and you're putting these two together. Typically, this would probably be where this would be an existing structure that you're welding to, and you're bringing in this new piece and trying to weld it to this piece. So what you bring this in already pre-beveled, and so you've got a bevel groove. The third type that we talked about is a fillet weld, and as I said, I've got this plate that is generally perpendicular. It doesn't have to be. It could be slightly less than perpendicular, depending on what you were putting in there. But you've got a square surface here and a square surface here to weld in between here. And typically I really can't, I don't think I can do this in 3D. if I try to put a chamfer in there, it's going to put a chamfer. Um, I need surfaces, not chamfer. This software does not lend itself to putting in uh, the chamfer would end up looking like this. So I'm not going to do it. What you need is an angle. You need a triangular piece here that projects out here would be a fillet weld. And so what I'm going to do is I'm going to go over to the drawing over here and I'm going to create a drawing. But this is a large drawing. This is too big. So I'm going to come down in size and I'm going to go to let's go to a B size. And I can bring this down. And I'm going to rotate it. I want to rotate it. I want my piece to look like that. And I'm going to move it. And I'm going to say OK. So now what I've got is this plate here that's vertical. And I've got another plate that is horizontal, as we saw. And I'm going to go up here to annotate. And up here, I can put in a weld symbol. So the software just allows me to pick where I want the weld symbol. And notice it defaults to fillet, because fillet is pretty much the most common. Now, the previous playing around with this, I wasn't using a fillet weld. So, and there was already a size put in there. Well, that's about right for this size plate. And up here, I'm going to put another fillet because I want it welded on both sides. I want it welded on both sides of this plate. So what I want is I want a bead on this side and I want a bead on this side that runs perpendicular to the page there. And we're going to put this in so that we're going to do 1 inch long every 2 inches. So we're going to stagger these, and they're called the stitch weld. Now, what I want you to get out of this is you're not going to be calling out the welds. What I want you to get out of this is how do you use this feature and put it into your drawing for this final, because you're going to be calling it out. But the welds are already called out for you for the final. You just need to know how to manipulate this feature of the software to properly put in the welds. So the next one was going to be this bevel groove weld, and I'm going to show you how to change that. Come down here and you're going to select the bevel groove, and again I'm going to delete the length because I want a full weld. So I'm going to clear this. You notice this and I'm going to clear this out. I don't want that. And I put a note in here on note 1. So note 1's got something to do with welding. So probably something to do with, like, refer to AWS, which is American Welding Standard, D1.1 or something to that effect for all welds, so that you make sure that you adhere to the welding standard. And but that's how you put them in there. That's how you modify them. You double click on them. But that's how you put the welds in. And you'll be required to do this on your final. Again, you will not be required to specify the weld, the size of the weld, or any of that. Everything will be given to you to put in the drawing. My expectation is that you will be able to put it in the drawing as it's called out on the details of the sketches that you're given. And that's all I've got for this. This is the quick and dirty welding tutorial to help you out, and I hope you have a nice day.